This is picture of condominium collapse in Surfside, Florida on June 24, 2021. I will explain the introduction of the condominium collapse in Surfside, Florida on June 24, 2021. This study analyzed the collapse, building overall performance and key component based on the building design codes. Punching shear and post-punching performance of the typical slab column joints are also studied through the refined finite element analysis. On June 24, 2021, at approximately 1:30 a.m., the Miami suburb of Surfside, Florida, United States, experienced a sudden partition collapse and 98 people were confirmed dead. Based on site investigation, many research has pointed out that punching shear failure at the slab column joints might be one of the most likely reasons. It was found that the post-punching bearing and deformation capacities of the slab column joints were predominantly determined by the true column integrity reinforcement, and the addition of the embedded beams facilitated greater deformation and load capacities in the largest deformation suspension stage. The visualized collapse simulation demonstrated that after the collapse of the middle part of the structure, the shear walls on the east sides were not strong enough to prevent collapse propagation. The shear wall on the west side, on the other hand, were much stronger and thus did not experience progressive collapse. In summary, the collapse structure has a low level of safety margin, robustness, and resistance to progressive collapse, which in general can inevitably lead to serious consequences if local damage occurs due to unexpected and unforeseeable reasons.
Types of corrosion is a galvanic corrosion, where the steel rebar embedded in the concrete corrode due to the presence of the chloride ion from seawater and other environmental factors. The chloride ion penetrate the concrete, reach the steel bar, and initiate the corrosion process. Over time, this corrosion leads to the weakening of the structural integrity of the building, contributing to its eventual collapse. Mechanism of corrosion. First is electrochemical reaction. The corrosion of rebar is an electrochemical process where iron reacts with oxygen and water to form iron oxide. The chloride ion accelerates this process by breaking down the passive protective layer on the rebar. Second is environmental factor. Proximity the ocean increase exposure to salt-laden air, leading to the higher concentration of chloride ion in the environment. High humidity and temperature in the region also contributed in the corrosion rate. Third is material properties. The concrete used in the construction may not have been adequately designed to resist chloride penetration. Lack of proper protective coating or sealant on the rebar exacerbated the issue. This is the diagram of the corrosion mechanism showing how chloride ion infiltrate the concrete, leading to the corrosion of the embedded steel rebar. It demonstrates the progression from initial chloride ion penetration to the formation of rust and the eventual cracking and spalling of the concrete. During the incident on 24 June 2021, the condominium is partially collapsed. Within a minute, first responders arrived on the scene to conduct rescue operation. Early hour, the magnitude of the collapse was evident, and the rescue team worked through the night to save as many lives as possible. Immediate aftermath. Search and rescue operation continued for weeks, with teams from across the country joining the effort. Unfortunately, only a few survivors were pulled from the rubble in the initial hour. A total of 98 people lost their life in the collapse, making it one of the deadliest building collapses in US history. Long-term consequences. Multiple investigations were launched to determine the cause of the collapse. Second is lawsuits were filed by victims' family and survivors against the condo association and others involved in building management and maintenance. The tragedy prompted discussion about stricter building codes and more inspection. The collapse had a profound effect on the local community and beyond, raising awareness about the importance of timely maintenance and structural health monitoring. On 1990 until 2000, early signs of the deterioration begins appearing, including cracks in the concrete and water intrusion issue. 2018, a structural report from an engineering firm identified significant structural damage to the concrete slab beneath the pool deck, as well as abundant cracking and spalling of the columns, beams, and wall of the parking garage. 2019 until 2020, residents discussed the necessary repair but delay in action due to the financial. 2021, plans were made to begin extensive repair as part of the building 40 years recertification process. However, the actual repair work had not commenced.
Surfside condominium collapse in Surfside, Florida was a tragic incident that resulted in significant loss of life and property. Below is the analysis of the factors. The first factor is the environmental conditions. Proximity to salt water. The condominium was located near the ocean, exposing its concrete and steel components to a corrosive marine environment. This salt-laden air and water infiltration can lead to chloride-induced corrosion of reinforcing steel, causing it to expand and crack the surrounding concrete. Over time, this weakens the structural integrity of the building. Next, the rising sea levels and flooding. The increasing frequency of flooding due to climate change may have undermined the building's foundation. Saltwater intrusion into the foundation can accelerate breakdown of materials, especially in poorly waterproof areas. Soil subsidence. Studies have indicated that the ground beneath the building may have been sinking over time, contributing to differential settlement and uneven stresses on the structure. The second factor is the design flaws. Inadequate drainage systems. Poor drainage design on balconies, roofs, or parking areas can lead to water pooling and seepage into structural elements. Persistent moisture accelerates corrosion and concrete spalling. Next is the flat slab construction. The building used a flat slab design, which lacks beams between columns to distribute loads. This design is more exposed to punching shear failure, particularly when combined with the breakdown of concrete and corroded reinforcing steel. The third factor is the material selection issues. Use of low-quality concrete. The concrete used had low compressive strength and high porosity, which are more vulnerable to cracking and water penetration. Now, the final factor is the operational practices. Delayed repairs and maintenance. Record shows that structural issues had been identified years before the collapse, but critical repairs were delayed. For example, there were signs of concrete spalling and rebar corrosion noted in the engineering reports as early as 2018. Lastly, inadequate waterproofing. The parking garage and pool deck reportedly had waterproofing issues that allowed water intrusions over decades, exacerbating structural damage. Surfside condominium collapse. Maintenance practices were insufficient to address the significant structural vulnerabilities that had developed over the building's lifespan. Below is an analysis of the key aspects of maintenance practices. Firstly, the irregular inspections. the Champlain Tower South Condominium Association had commissioned engineering inspections, including the notable 2018 Structural Engineering Report. This report identified major structural issues, such as concrete spalling and rebar corrosion in the parking garage and pool deck. The 2018 report explicitly warned about the need for extensive and timely repairs. However, there was a significant delays in acting on these findings, and the building did not undergo the immediate remediation recommended by the engineers. Secondly, the corrosion protection measures. Evidence suggests that, such as applying waterproofing membranes, ensuring adequate drainage, or sealing cracks in the concrete, were either inadequately implemented or had degraded over time. The 2018 report noted that the pool deck waterproofing had failed, allowing water to seep into the concrete slabs below. This prolonged exposure to moisture facilitated the corrosion of the reinforcing steel in critical load-bearing areas. Next, the maintenance records. Available records indicate that while some repairs were made over the years, they were largely piecemeal and reactive rather than part of the comprehensive maintenance strategy. Routine maintenance work did not address the seismic structural vulnerabilities noted in the engineering assessments. The condominium associated struggled with budget constraints and internal disagreements, delaying critical repairs. For example, residents were reportedly reluctant to improve a $9 million repair plan proposed in 2018, even as costs escalated to $15 million by 2001. Lastly, the missed opportunities. Failure to act on warnings. Despite the clear warning signs outlined in the 2018 report, no significant repairs were initiated until just months before the collapse. By then, the extent of the damage had likely reached critical levels. Inadequate long-term planning. The Condominium Association did not establish a long-term capital reserve fund for addressing large-scale structural issues. As a result, essential repairs were delayed due to the high costs and lack of financial preparedness. Error during the manufacturing and construction process may have contributed to the Surfside condominium collapse. Each of these errors are explored below. First of all, are the errors in material selection. Use of substandard concrete. During construction, if concrete with inadequate compressive strength or high porosity was used, it could have accelerated degradation when exposed to environmental conditions such as salt-laden air and water. Poor quality concrete is more prone to cracking, which allows moisture to penetrate and corrode steel reinforcement. Next is the improper waterproofing materials. The failure to select durable and long-lasting waterproofing materials, particularly for the pool deck and parking garage, contributed to water intrusion that promotes corrosion. Second of all, the inadequate quality control. Improper concrete pouring and curing. Errors during the pouring and curing process of concrete can lead to uneven strength distribution, shrinkage cracks, or weak spots. If construction crews did not adhere to strict quality control measures, these flaws could have compromised the building's structural capacity from the start. Next, the rebar placement errors. Incorrect placement of insufficient spacing of reinforcing steel can result in inadequate load distribution or insufficient concrete cover, exposing the steel to moisture and accelerating corrosion. Quality control ensures that materials and workmanship meet design specifications and standards. Lapses in quality control during construction could result in latent defects that only become evident years later under stress or environmental exposure. Furthermore, the misinterpretation of corrosion signs. Failure to recognize early warning signs. During inspections or maintenance, visible signs of corrosion such as rust, stains, spalling concrete, or cracking may have been misinterpreted as superficial or non-critical. This could have delayed necessary repairs or underestimate the severity of structural damage. Next, underestimating progressive deterioration. Structural damage caused by corrosion is often progressive. Early-stage issues may have been dismissed or addressed inadequately, allowing damage to compound over time. Recognizing and addressing signs of corrosion is critical for preventing structural failures. Misinterpretation of these signs likely allow the damage to progress to an irreversible state, ultimately contributing to the collapse. Human error during manufacturing and construction, ranging from poor material selection and inadequate quality control to misinterpretation of corrosion signs, likely play a role in the long-term vulnerabilities of the Surfside condominium. These errors, compounded by environmental exposure and deferred maintenance, created the conditions for structural failure. Onto the prevention suggestion. These are the recommendations that can be made to prevent similar incidents as the Surfside condominium collapse in Surfside, Florida in the future. Firstly, material selection. Future construction projects in coastal areas must prioritize materials with proven resistance to corrosion, such as high-strength concrete and epoxy-coated rebar. Design practices. Design buildings with elevated foundations and advanced drainage system to mitigate the effects of flooding, rising sea levels, and water intrusions. Next, weight distributions. Avoid overloading structures by using lightweight construction materials where possible. Ensure proper distribution of load across structural elements to avoid overloading specific areas. Next, modern technologies. Use artificial intelligence, AI, to analyze structural health monitoring system (SMS) data and predict potential failures before they occur. Installation of AI sensors to monitor the critical parameters such as corrosion rates and vibrational levels. Training and expertise. Inspectors and maintenance personnel should receive specialized training to identify and address corrosion and other structural issues accurately. Regular inspections and funding. Mandate comprehensive inspections of older buildings at more frequent intervals, such as every 10 to 20 years instead of 40 years, to detect early signs of deterioration. Establish mandatory capital reserve funds for condominium associations to ensure sufficient resources for large-scale repairs and upgrades.
The Surfside condominium collapse share similarities with several other incidents worldwide, where structural failures were influenced by corrosion, material degradation, or improper maintenance. So the table shows a comparison of 5 similar cases. These are the common factors and lessons learned. First is environmental condition. Second is material and design flaw. Third is inadequate maintenance. Fourth is human error.